In this tutorial, you'll learn how to set up and analyze a heat transfer through conduction between hot and cold particles. Start by setting the units for the simulation. Next, add a bulk material and rename the material to plastic. Define its properties and interactions. Create a single sphere particle and name it. Next, define the equipment material. The geometry in this tutorial is made of the same plastic material that was defined for the particles, however, bulk materials can only be assigned to particles. Therefore, the same material also needs to be defined as an equipment material. Next, create a container for the particles by using a box geometry with the specified dimensions. Then, create a particle plate and set the geometry type to virtual. Finally, position the factory geometry. In this simulation, two particle factories are required, one to generate hot particles and another for cold particles. Both factories can use the previously created particle plate geometry. Set the factory type to dynamic. Set the total number of particles to be created for both factory types. For the cold factory, set the start time to 1 second. Next, you have to define the physics for the model. For this simulation, the Hertz-Mindlin with heat conduction contact model is used to represent the heat transfer between particles of different temperatures. Choose particle body force interaction and select temperature update. Next, you must define the specific heat capacity of the particles. Finally, set the particle to geometry interaction using the following thermal conductivity and temperature values. Next, you have to define the hot factory's initial conditions. Set the temperature to fixed with the following value. Repeat similar procedure for the cold factory, and set the temperature to 300 kelvins. Next, move to the simulator. Set the simulation parameters, including the time step, simulation time, and the target save interval. Then select your simulator engine, and run the simulation. Once your simulation is complete, move to the analyst. The display section in the analyst tree is used to configure how the different elements in the simulation appear. Color the particles according to their temperature, assigning colors to represent the minimum, medium, and maximum particle temperature values. Set the minimum and maximum temperature values to 300 kelvins and 500 kelvins. Then, add a legend and rewind the simulation. In the viewer window, label the cold and hot particles. In the viewer controls, set the step factor to a time value of 0.02 seconds.